Welcome to the Breakpoint, episode 5. In this episode, we're going to do kind of a grab bag of Chrome DevTools features. Stuff that you probably haven't seen, kind of some new stuff, but we're going to cover all of DevTools. So we're going to start off doing some kind of mobile overrides and kind of emulating mobile environments while still on your desktop machine. We're going to transition, do some CSS stuff, showing off the CSS Regions support. And we're going to get into JavaScript, show some kind of insight that we have into internal properties and bound functions, even do some native memory profiling, so kind of spanning the gamut, but showing you things that you probably haven't seen, some power inside your DevTools that you'll be excited to play with. So to kick this off, Addy over in London is going to show you, what are you showing? Some mobile stuff?
I'm going to be showing some mobile stuff today, but before we get started, I wanted to wish everybody in DevTools land a big Happy New Year.
Oh.
Happy New Year, Pony.
That's very nice. That's styled console logs?
Yeah, it's styled console log. We showed this a couple of episodes back. This is all I've been playing with during my holidays, and now I am very, very happy to be showing it off. But we're going to be talking...
I think that styled console logs can't really augment with some ponies and happiness.
Yes, if you don't have ponies in your DevTools, you're doing something wrong. Right. So for the first part of this show, we're going to be talking about mobile. Now, increasingly, users everywhere, regardless of what type of app you're having, are interested in accessing your web apps using some sort of mobile device. And a lot of time, you want to make sure that you're delivering them the best experience possible. Now, from a development side of things, this often means either having to debug your app using an emulator of some sort, or even worse, having to actually play around with a device or multiple devices just to see how well things work. So we've actually introduced a bunch of stuff in the DevTools to help with this workflow. And I'm going to show you some of this stuff today. Now, the first tip I'm going to give you before we actually start playing around with this a lot is that you can actually debug or try out how different layouts look. So if you're using, say, media queries, for example, to offer people different layouts and adaptive layouts for your apps, you can actually use DevTools in dock to write mode, and you can just use the slider to actually increase how much of the page is visible. And if you keep on moving the slider, you can actually see different versions of your layout depending on the different breakpoints you have set up in your media queries, which is kind of nice. But what we're going to be talking about next is actually overrides. So probably in the first episode of the Breakpoint, we mentioned that we've got a ton of override capabilities available if you have the DevTools experiments enabled. And we're going to talk through some of these. Now, let's say, for example, that you want to see how your web app might look if you're on iOS and perhaps on an iPhone. Now, if you pop open DevTools and go to Overrides, which is in the Settings cog, so click down in the Settings cog, go to Overrides, and select User Agent, first of all, and then select a device. So we have a ton of device names available here. We've got sort of iPads, iPhones, Android devices, and a ton of other stuff. Now, if I select, for example, iPhone with iOS 5, what you'll see has happened is it's actually gone and resized my viewport so that I can see what this might look like on an iPhone. Now, I haven't had to pop open an emulator of any sort. I can just see directly inside Chrome what this looks like. What you'll see below this is that we've got a section called Device Metrics, which will tell you what screen resolution it's displaying for your app at the moment. Now, you can manually go and customize these details as much as you want. It'll also try emulating the font scale factor, so it will show how your fonts might look in that device too. But it's very, very easy to go and switch between device types. So if I wanted to switch and go to a Nexus S, for example, I can do that. As you can see, the layout on my web app has automatically changed. And it's just a very easy way of seeing how your app or site might look on a different device, which is kind of neat. Now, another thing that you're going to be dealing with a lot of time on mobile are things like touch events. And touch events are difficult. I'm going to throw open a quick touch demo. Now, this is something Paul created. Paul, you created this a while back. This is like a little finger painting demo.
Yeah, it stems because I got this question of someone was like, can we do a multi-touch application with Canvas on the web? Because everyone thought that you couldn't properly do multi-touch. And so this was a little demo to kind of show that you can, in fact, track multiple touch points on the web, and it's not a problem. So it works.
That's pretty neat. So if you were to what I'm doing at the moment inside this canvas area is I'm actually trying to drag my cursor around. And what you'll see is that nothing's really happening because this demo actually relies on touch events, which you'll probably find in a mobile device, but currently not on the system I'm using at the moment. So what I can do in DevTools is go back to my overrides, and near the bottom you'll see an option called Emulate Touch Events. Now if I check this and I go and I reload this app, so it should be reloaded, I should now be able to go and draw using touch events. So, whoa. Wow, this is insane. I love this.
Nice.
Ah. And that's awesome. Again, it means that you don't have to go and pop open a device or an emulator to try getting this working, which is pretty cool. What's also nice is that not only are you going to get sort of touch events working when you're trying out demos or trying out bits and pieces of code, but if you use Modernizer, as so many people do, you can actually emulate. So I'm in a different tab. I'm going to make sure that Emulate Touch Events is in here. What you can see at the moment is this is using modernizer.touch to check if there's touch event support available locally. Now, what you'll see in the first column is onTouchStart isn't present. If we were to scroll across, we see that onTouchEnd is also not available. Now we can actually emulate this. So if I were to just reload this page, you should now see that onTouchStart is available in Windows, and onTouchEnd is also available too.
Yeah, and actually, you're running Canary here, aren't you?
Yeah, I'm running Canary.
Yeah, because just like, it was like 2 days ago, one of the last ones, I think it's window.touch maybe, that was also added to the list. So it is removed as a global constructor when touch is not available to the browser. So,
nice.
So the detect that Modernizer uses here is onTouchStart, detecting to see if that that event handler attribute is bound. But some other people use other things. Anyways, the touch story for feature detection in WebKit now is really nice. So we'll actually probably be publishing an article pretty soon on how to detect touch, all the different types of touch event models, and deal with that pretty soon.
Sweet. So the next thing we're going to be looking at, so we've talked about touch, we've talked about sort of device metrics. The next thing we're going to be talking about is orientation. Now, because mobile devices offer us a few other capabilities, like being able to tilt the device in different directions or accelerate the device depending on how you're actually moving it, that gives us a whole range of other capabilities we can build into our apps so that we can react on them depending on what someone's doing. Now, again, this is usually something that you'd have to be using, a device to test on or an emulator to test on. But again, we've got support for this stuff inside the DevTools to make your debugging workflow a little bit more easy. So I've currently got a HTML5 Rocks orientation demo open at the moment. And if we look at overrides once again, you'll see a section called Override Device Orientation. Now, what this allows me to set is a few different parameters defining, what direction the device is in, what acceleration the device has got, is it being tilted from, the side, is it being tilted from the front, and so on. And I'm just going to show you how this works. So let's say that I'm changing, I guess this is the vertical acceleration. Let's say that I set this to 60. What you'll see is that this has gone and it's actually changed the acceleration that's being shown on screen for this particular demo. And I haven't had to go and open up a separate device to try to test it out. Let's go back to the overrides and let's play around with sort of tilt. So let's say that I change that to 50. What you can see is this is probably what it would look like if I was holding a device this way. But it just means that you can go and test out those different directions and orientations that you want someone to be able to do things with inside your app just using the DevTools in Chrome, which is, again, a nice little time saver. So another thing I'm going to show you right before we look at a few things like CSS Regions is something that was added, I think, just before Christmas, wasn't it? Emulating CSS media types. So emulating CSS media types is pretty cool, and I'm going to be using Smashing Magazine as an example of this. So we're going to go to Smashing Magazine, going to pop open the DevTools, we're going to go straight back to overrides, and at the very bottom you've got an option that says Emulate CSS Media. Now, the thing that this is really useful for is actually seeing what your different style sheet, your media style sheet types might look like. So at the moment I'm emulating the CSS media print type. And you can see this is pretty much what Smashing Magazine would look like if you were to go and print it out. You can see that all the links have been normalized to a more readable type of text. They've dropped some of the different styles and colors and images from their page. And it just means that you can see what your different style sheets for different media types might look like without even having to go and debug with a different page or add any custom code to switch those things. And it's, again, a nice little time saver. So I'm not sure what other types they might have on this page. So you can also try out handheld. So it looks like Smashing Magazine has a media type enabled for handheld, so I can see how that might look as well. And it's, again, one more thing that you can use to try saving you some time.
Yeah, I used to, on this one, I used to I would just go in the DOM view and find the style sheet for print and just change media equals print to media equals screen and fake it. But this is proper print application, which may even take advantage of some of the print-specific styles, like page break before.
Yeah.
But anyways, it's certainly a lot handier to check your print styles.
Yeah, and that's definitely something that can save you some time. Now, the next thing we're going to be taking a look at is CSS Regions. Now, while I'm opening up the DevTools, Paul, do you want to explain what CSS Regions are, just to remind people?
Sure. So CSS Regions basically allow kind of magazine-style layout. And what this means is you can define your layout of text. So I have a div here, and I have a big picture right next to it, and then like kind of a column, 3 columns of text underneath it. And so you can really have a lot of control over the exact layout of your boxes of images and text. Now currently, CSS multi-column allows you to split up text into columns, but it doesn't allow things like dealing with this kind of magazine-style layout. It's more just the simplistic, I want things in columns. So Regions lets you define these boxes just using divs, and then you basically say, I have a big div full of text. Please have this text run through these boxes around the side of the image. And it kind of just flows through and deals with the breaking into words as things fit. So it allows you to kind of have very good control on the size, layout, etc., using any sort of CSS that you want, and then you can just flow text through it.
Cool. So the demo that we've got open at the moment is one from Adobe. The title of this is Adaptive Layout with Media Queries and CSS Regions. And basically what happens is once I actually resize this page, what you'll see is that the text content is going to start flowing between different columns. And this is using a combination of sort of media queries and CSS regions to happen. Now, inside the DevTools, if you want to get the ability to actually inspect the different regions inside your CSS Regions page, is you can go to Experiments, and there's an option here that says CSS Region Support. So you enable that, go and you refresh your page. Now, let's say that I want to select something in here. It can really be anything. Let's inspect an element here. We've got a paragraph. Now, when I right-click on the DOM element that I've selected, and I go to a new place called CSS Named Flows, what'll happen is a new panel is going to open up at the very bottom that's going to basically describe all of the different regions that describe this layout. So what you can see is we've got a region chain describing region 1 and region 2. There are 2 specific regions inside this page. It'll also display the content for specific regions if you want to dive down into that. And what's really nice is you can actually go and select a region, and it'll reveal the elements in the Elements pane that make up this region. So I can go and I can dive down into these and further style them if I want and just debug them, which is quite nice.
Yeah, I like that. And so we should point out that this cool patch, this feature was added to the DevTools by Adobe, contributed this. Do you want to show, Addy, do you want to show how to enable this feature?
Yes, of course. So once again, you have to be inside the Settings cog, go down to Experiments, and enable it using the CSS Region Support option inside Experiments. And then all you have to do is just refresh your page, and you should be able to start inspecting CSS region-based content and just going and seeing the CSS named flows inside of there.
All right.
Cool. So
am I going to show some stuff now?
I think you are going to be showing some stuff. Do you want to? I was going to show the sort of selector highlighting. Do you want to show that?
Sure, I'll do that.
All right.
All right. So we'll come over to me, and the first thing that we're going to take a look at is the new well, newish, selector highlight. So here's an example here. I've just selected this run button up inside JS Fiddle. And on the right-hand side, we have my styles. And this happens a lot where you create a big style chain of selectors, and then you're applying some things to it. And so in this case, we're just applying some common things to all buttons. But sometimes it's a little hard to see exactly which selector that you authored matches this particular element. So now it's just a little bit more clear that this element in black is the actual one, in this case, that the DOM matches. So it should be helpful. I think Oliver J. Ash, a developer in the UK, requested this. And then I was like, file a ticket. And then he did. And within like a day, it was in the tool. So it was a fantastic feature request. And I think it's much better now that we have that in there.
That's amazing. It's also a good reminder for people that want to get new features landed in DevTools to just go to crbug.com, right?
crbug.com/new, file it, ping Addy or me, and we'll take a look and try and make it happen. All right. So now that we've kind of seen the mobile side of things, the CSS side of things, we're going to transition into a little bit of JavaScript. So I'm over here in JS Fiddle, and the JavaScript that I have up on the screen right now is basically a way to look at how closures operate. So we have an external function called A. Inside of that, we have a little array, which takes the arguments passed into A. And then what A eventually ends up returning is another function, which we're internally calling B here. And all that's going to return is the index of this trapped array that was passed in. So we will construct a new function here by passing in here I am. This will return a function into our B. And then if we call B, passing in an index value, we should see that. So just to kind of, if we run this, we log to the console the I from the middle because we're logging out the 1. That makes sense. But a lot of times, your applications are a bit more complicated than this, but you're still dealing with this kind of concept. So we have some new features inside the debugger that allow you to see this a bit better. So if I just hit run so I can trap this again, I'm trapping with the debugger keyword here. And I'm going to add a new watch expression up here, which is B. And a new thing that you're going to be seeing here is this new function scope expando. So you open that up, and you can see the closure that is inside of your B variable. So this is the little function. And then inside there, you can see that the array was trapped, and you can inspect it. So here you're able to kind of investigate the scope within that function and see what is captured within that closure, which in a lot of cases is really, really useful. And we're able to explore that from the function or from the object itself, rather than looking only at what's inside, say, the scope variables, which is a kind of a different approach to look at this. All right. So that's one new one. And then another new thing. So first, I'm going to explain the JavaScript. We have a little summing function. It takes 2 arguments, and it sums them. Makes sense. Then we're going to take that summing function, and we're going to use function prototype bind and bind it to a null scope and an argument of 1. OK, and we're going to save that function into the inc variable. So now I'm going to run this again. Great. And again, I set up some watch expressions so we can see a little bit of what's going on here. So there's 2 things to note. One is that inside sum, we immediately see what the function value of sum is, which is pretty useful. I should point out that you can always right-click here and jump to the function definition, which is right here, but I'm broken, so it's a little funny. But then our bound function, which we use right here, we can't actually see what the source of it is. It is a native function because we used function prototype bind, so we can't actually see what's going on. But if we open up the function, we have these new properties down here. So we see the target function. And so this is the function that was bound using the function prototype bind. We can investigate that just the exact same way. And we can also see what our this argument, what was passed in as the first argument to function bind was, which was null, which we passed up right here, and any arguments. So our arguments array just has a single argument, which is 1, which we passed right here. So here at runtime, we're able to see a lot more insight around functions that were binding, functions that were bound with any new scopes and new arguments, which gives a lot more insight into how this works.
That's awesome.
All right, cool. Next, we're going to come over to the Google homepage because I'm going to show native memory profiling. So just pop open the DevTools, and over on the Profiles page. So this is, what I'm about to show is another experiment, which you can just enable over here in the experiments. I keep them all enabled pretty much always, but I don't know if I recommend that. There's a big red warning at the top of this, so that's up for you to decide. But if you have them all enabled, you're going to see this guy. So this is a live updating chart of the memory usage. And you're also going to get this native memory snapshot. So I'm going to take one of these because it gives a little bit more insight. So I take it, I view it over here. And here we can get a little bit more insight into the actual memory consumption of the page. So 32% of it is captured by the JavaScript heap itself. And we can investigate more about that over in the actual heap profile. We have, looks like the inspector, the DevTools, are using 9.2% of the memory, and we can see how that kind of lays out. The page structures and the in-memory CSS DOM stuff that WebKit and WebCore is using, and everything else. So this is really useful if you are also working with the heap profiler and trying to identify where your memory is being consumed. This is currently still an experiment. It's getting more commits every day, so things might break, but this is a good little preview at this new feature. Next, we have another new feature in the JavaScript profiler, and this is the ability to see the difference between idle time and time that is spent elsewhere. So previously, if you ran a JavaScript profile, you might notice that a lot of the time in your CPU profile was consumed by program, and it would be like I would try and identify why my JavaScript is so slow, but at the same time V8's really fast, and most of the time is spent elsewhere. So this mysterious program block would consume maybe about 95% of my time. I didn't really know what was going on, so here we have a little bit more of a better idea. So this demo here is this kind of cool. It's like parallax. I think there's a. But I really like this kind of effect, this 3D kind of layers merging effect. On the video, I think you might be able to see this. It's kind of chunky, these transitions. And so I saw this yesterday, and I was trying to figure out why it was so chunky. I go over to timeline, I start recording, and I'm recording, and these frames are huge. These frames are absolutely massive. But at the same time, so we're busting way above our 30 FPS, but they're not really filled with anything too useful. So then I was like, maybe it's in the CPU profile. So I'm going to collect a new CPU profile and move it around. Get a little bit of action there. Come back. And here's the most useful part that we have, which is any sort of idle time, which is just captured by CPU's not busy at all, is clearly called out as idle. Before we didn't have this inside Chrome, so it's great to kind of have that very explicit. Program, when you see this now, this basically means the browser was busy. The CPU was busy doing other things, in other tabs, or something that we just don't know about. We know it was busy, and so we can say it might have slowed down other things. You shouldn't expect to see program now at around 90. If it does, it means your page might be slowing down, but it's not this page's fault. And then, of course, any other JavaScript on the page you can investigate. So anyways, small thing. Gives a lot better insight into what's actually going on. All right, WebSockets. Addy, if you can join me over here on this little demo.
Yes, I will.
All right, so before we've been able to see that there are WebSockets and they are connected in the network panel. We can just select WebSockets and see that there is a socket connection. And now we can also see what that actual data is. So I can say, you said hi. Hi, Addy. All right, send me one more message. Nice. All right, cool. So inside this little frames view, we're able to see what the actual data that's sent over the WebSocket is. I should point out that you right now when you want to get this updating, you have to click again on the element on the left-hand side for the frames to update. We will be fixing this soon. Just kind of have to deal with it for now, just to get the live view. But you can investigate exactly what data is going over the WebSocket, which can help a lot when you're debugging the situation. While we're on the topic of network, a cool thing that you can identify now that most people don't recognize is you can find out what kicked off a network request. So I'm on Amazon right now. I'm going to bring up network, and I'm going to refresh the page. All right. So Amazon, only 1.7 megs. Man, they are professionals. All right, so looks good. There's a lot going on here. We can see a timeline, and we can resort this by how long things took, or just view the normal waterfall. But in the middle is this initiator column. And we can identify why the browser is making this request at all. So let's say this one right here is this CSS. The CSS is being requested because of the parser, which is the HTML parser. And we can click through and identify exactly where the request came from. So this link tag. So this helps a lot of times. Sometimes you'll just see this request go on in network or come through a proxy and be like, why is this file ever being requested? You can find out why. So that one's coming from the HTML. That one's pretty easy. But a better example might be this one's coming from script. This is a little navigation image. It looks like a sprite. And it's actually being requested by a script from inside of jQuery. So we can see the full call stack. This call stack was added last week, in fact. And then find out what's going on inside here. So anyways, that gives a good amount of insight into why these requests are going on. So if you have a stray request that you want to track down, it's a lot easier these days. All right. I think the last two things I'm going to show are part of the console. So one of the issues that we had a little bit ago was that our console logs inside the Chrome DevTools, they log very fast, but we used to actually, when there was a complex object coming in, it would reveal the exact value of that object only when you kind of expanded the little arrow. So I'm going to show an example here where I take an array, I kind of decrement the values inside the array, and I log out the array each time I do that. So right now, we actually get a little preview now. Before, this would just say object, and it had that arrow, and you kind of look into it. Now you'll get a preview. So this preview is generated at runtime. But if you open it, it'll actually be the current values. So that's why this might look a little bit confusing to you. You might see -1, 1, and 2 in the preview, and then -1s down here in the live view. So that's just kind of the way to keep in mind of how this works now. So it gets snapshotted and logged out in a preview, but when you expand it, it is the current value. So I'm happy now that we have this preview, and it's a lot more functional than just the term object, I think. All right, the last one inside the console is dollar underscore. I believe this comes from Perl. The underscore refers to the last computed value. So back on the Google homepage, I have this element selected, the search box, and let's see, I want to find out the width of it. Cool, so hey there, $0, come on. Nice, all right. So, $0 offset width. So the width of this box is 606. What I'm going to do is add 200 to that, so 806. And now I just like to make that the new width. So I'm just going to say, set the new style of the box to be that computed value. Let me bump this font size up a little bit. That computed value plus the term pixels. And now we grew out our text box. So we're just referencing whatever was the last computed value. I'm going to change this back down to minus 500 from what it is now. So we're going to have a computed value of 308. And then just use that and jump down. So this is really handy if you're doing anything complex doing any math or doing anything else in the console and just want to reference the last thing that was there. It could be an object. Let's say I am selecting $0 for this form, and I could do reference the style element, the style object of the element that I just logged. It's kind of up to you. And I think this is actually, we'll have this as part of a new set of docs for the Chrome DevTools, as this is a new feature. This will be included in the new docs that we are putting out pretty soon, Addy?
Yes, pretty soon, hopefully in the next couple of weeks.
Not bad. So you're going to be able to check out the full range of what's available inside the Chrome DevTools console, and a bunch of other stuff with a new refreshed documentation experience that I think you'll like. All right, Addy, are we done on this? We cover a good.
I think we're done. Right before we go, I just wanted to give a shout out to 2 Chrome DevTools extensions that have recently gotten updates. I'm going to flip over to my screen really quickly. So the first one is Rails Panel, which I saw over on Plus a few days ago. But basically, Rails Panel is a Chrome DevTools extension that gives you lots of insights into things like rendering times, requests, and a lot of information specific to Rails apps. So for Rails developers that love using DevTools for their front ends, this is just a really great extension for getting more information about what's going on in your application. Another one that's gotten some nice updates recently is AngularJS Batarang. We've briefly showed it while I was flipping through on one of our other episodes, but basically Batarang gives you insights into your models and directives, and it helps you profile your Angular apps, so you can help improve the performance of your apps pretty well there. And yeah, that's it.
Looking good. All right, we'll see you guys next time.
See you next time.
Cheers.